Okay, so we've learned technical regression. It is a very useful tool to find out the correlation between different variables and also can forecast some data based on the information we have. And today we will dealing with a new area. We also do forecasting, but it's a little bit different. It's time series. The difference from time series to normal regression is the time series based on the time. Maybe it's a little bit confusing, but think about the time series. Time series is saying that today's price, for example, let's say price. Today's price is based on mostly based on the yesterday price. It's continuous changing, right? So today's price would based on the price before. So let's take some examples here from the lab exercise to show you how it works. Okay, so we only have two questions. First question is a little bit easy. We will use two technique here. One is called moving average, and the second one is called exponential smoothing. And question two, we will use the seasonal decomposition to do a regression on data. So first, let's look at question one. We need this gasoline price data file. So go to Sakai to find the data and open it. Give you a few minutes. If you have the data opened, you will see the data exists, right? There are two columns in data file. One is date, another one is price. Right? You will see the number very close to each other, especially for the previous one. That is because the price is majorly based on the previous one, right? It's self-increasing right here. So it doesn't have any correlation between the date to the price, right? If I give you no information about the price, only give you data, you cannot do any prediction just based on this column, right? So that is the difference between the time series to the price. Sorry, time series to the regression. And here we will use two approaches to make a prediction on the price based on the date. So first one is called the moving average, right? So for moving average, let's say first let's do the moving average 3. Right? Moving average is calculate. For example, let's say we want to calculate some days price here. We want to predict. Assume we don't know this price yet. We want to predict at this point. We want to predict the following price, right? We're standing at January 17th. Want to predict January 24th. And what we do is we use the information we have. We just calculate the average, right? So that is average the previous 3 days price. Okay. And for the next day, right now we get this prediction. For the next day, we do the same thing, right? We use these three. We use these three as input to predict the next one, right? This is the average. These three. Okay. Notice the only difference from here to here is the input box just going down for one cell, right? So what we need to do actually is just double click to fill it down by the Excel filter. Right. Then we have the moving average. Right. This is moving average. And notice that we cannot predict this string because we don't have enough data to create average. So if we use moving average string, we will skip the first string. Right. By the same way, if we want to calculate moving average 5, right, we skip 1, 2, 3, 4, 5. Skip 5 cells. Right. We start from here. Start from here. Then we calculate average here, right? Moving average 5, we use previous 5 days. Moving average 3, we use previous 3 days. It's moving average 5. Okay, so this is not required by question, but that's the way how you calculate different periods of moving average. Okay, so another way to do that is do the exponential smoothing, right? Let's do exp here. And for this one, we need alpha, right? We need alpha. The alpha would the alpha is defined by the question. So let's go back to the question. I think it's 0.2 here, right? Alpha is 0.2, which means what? Let's think about the problem for the moving average here. Right, moving average. For example, let's pick any prediction here. We only use the data for the previous 3 days. We ignore any data before that. It is a waste, right? Now you guys know that data is money, right? We have those data, but we don't use it. That's a waste. So that's the problem for moving average here. For the exponential smoothing, we want to try to use at every point, every data prediction point, we want to use all the data we have. We don't want to waste any data. For example, let's say we don't have to, at this point, at the first day, we cannot do any prediction because at this time, we don't know this price. We know nothing, so we cannot predict. And the second day, we only know the previous day, right? We only know the previous day. That's the only information we have, so we have to use it. Nothing to do here. And the third day here, now we have 2 prices, right? We have 2 prices, and we could use all of them, right? We could use all of them. So what we do is we use 20%, right? 20% of the previous actual price, right? Previous actual price plus 1 minus 20%, right? 20% multiplied by previous prediction. Right, let's finish this result. Okay, this prediction. Think about this. This prediction is based on the first day. If um, we use the price here and I use the price here, right? Which means we use both the first day and second day, right? And we can drag it down. Right? For any data entry here, for example, let's say the third day. The third day here, we use the previous, the first day, fourth day. We use the previous day's data and the previous prediction. And the previous prediction use the day 1, day 2, right? So which means this one contains this purple one contains the information in the day 1 and day 2, and we plus the day 3. So which means this formula used all the information from day 1, day 2, day 3. Right? That is the exponential smoothing, right? For the exponential, it's better to put the alpha in some cell, right? Some Excel cell, so we can change that easily, right? Okay, so this is the exponential smoothing, and the question is also asking for the Excel analyst tool. Let's do that. Okay, so we know how to calculate the moving average. That's another way to calculate the moving average. For example, let's say 3. Go to the data analysis, right? Find the moving average. Moving average here, right? Input range is the price. That's the price. Right? We have label, right? Interval is how many periods we want to string here. So output, choose the output cell from the second day. Okay. Now you can see the prediction is the same. Right, the prediction is the same. And you can also see actually Excel created the formula for us. Created formula for us. The formula is same as well. Okay, let's do exponential. Exponential result 0.2. Okay, so do data analysis. Go to the exponential smoothing. Right? And what we can do is input range. We use price to the button. We have labels, and this factor is 0.2. And output range we want to put from second cell. Okay, go. Okay, we can also see. Also, this one should be from first cell. So we can see the data is, the result is the same. Oh, sorry, there's a problem. Here the data analysis, we need in the exponential smoothing, this interval is the opposite to the alpha, so we need to use 0.8 instead of 0.2. Then we do change the output here. Change the output here. So okay, now you can see the result will be the same. Just remember the in the exponential smoothing data analysis tool, the parameter here, which is called the damping factor, right? It's 1 minus alpha. Okay, that's the only thing you need to do. It's very easy to use. Very easy to use. Right? Either way would be fine because you will see from if you are doing that for the lab test or the assignment, I won't know which way you use because the Excel analysis tool also gave you the function here, right? It's the same, exact same. If you don't remember the function, you can just go to the next tool for this. Okay. The third part is using the MAD, MSE, MAPE to find the performance. Right. So first, let's do MAD, mean absolute difference, which is, for them say, do MA3, MA3. Okay. So this is a measurement how good your model is. The calculation is, so we do MAD, we go backward, we go calculate D. D is the difference. Difference between what? Between your prediction, the first prediction is here, your prediction and the actual value is here, right? And we want the absolute because we want to turn the negative to positive. ABS, right? Just double click. Right, this for everyone is calculate the difference between that. It's like a regression residuals, right? So then after that we want average of all those, right? Our average, how much mistake we made. Right? This is the moving average 3. Okay, we also calculated the MAD for the exponential here. Right? The way is the same. We use ABS, right? ABS. The prediction we can calculate from here. ABS. The prediction minus actual value, right? And drag it down. Calculate the average. Average here. Okay, so then we can compare which one is better, right? In this course, the lower one is better, right? The lower the arrow, the better the model. Okay, so we will choose over every here. Okay, then we want to calculate the MSE. Right, the only difference is MSE is just the square of the MSE, MAD for every data entry. So which means it is same thing. The prediction minus actual, and we want powered by 2, right? Powered by 2 for everyone. Right? You know the number is smaller because it is less than 0. Less than 0. We can also calculate the MSE for the exponential smoothing. Equal to the prediction minus. Oh, sorry, it's not here. It's here. Prediction minus the actual value and powered by 2. Same here. So okay, we also want to calculate the average for those two, right? So this is the MSE and the same, right? The moving average swing has a lower MSE than the exponential smoothing, so we pick this one, right? The last one would be MADE. MAP, sorry. So it's a mean absolute percentage error, right? So the only difference between this one, MAD and MAP, right, is we calculate the percentage compared to the origin price. So that is still we calculate the absolute difference, right, between the prediction to the actual value. Then we divide by the actual value, right? Divided by actual value. So we get the percentage of the error. Okay, so percentage of the error. We can also do that for the exponential smoothing. So first calculate the ABS of what? Of the prediction from the exponential to the actual value here, and divide by actual value. Okay, so this is one. Now we want to calculate the average here. Swing MAP is EXP. Okay, so still the 3%. Normally we use these two. Use the MAP as a percentage. How much percentage is the difference, right? We will say still the moving average swing is better than the exponential smoothing in terms of the error, right? The error rate. Okay, that's for the question 1, and this is more important than question 2, though the question 2 is more complex, but you should know this um, knowledge very well, right? Let's say the moving average, right? Exponential smoothing, and MAD, MSE, MAPE, right? You should know these concepts very well for both the lab and the test.